Everyone uses the Q word, and by that I mean the word quality, of course. But what is quality? What does the word actually mean? It seems to mean everything generally good to everybody. But in fact, there's a whole range of types of definitions for that word, for different purposes, obviously, in different industries, of course. I'm going to talk about 8, just to give you a sense of the difficulty we have with this single word. Certainly, if you're talking to someone and they're using the word quality, you need to understand what their definition is for you to understand what they're actually talking about. I have to say that I generally try and avoid the Q word, but it's a kind of a necessary evil. It's a shorthand for good versus bad, acceptable versus not acceptable, perhaps. It's a commonly used word, of course it is, it's everywhere, and in job titles as well. But does the word quality really belong in an engineer's vocabulary? There are more definitions of quality than almost any other word in our vocabulary. So I want to look a little bit more closely at some of the types of definitions that are out there that actually get used. And I'm drawing on an article on a website, the link you can see below, suggesting 7 variations of definitions of quality. I'm going to add an 8th, by the way. The first one is fit for purpose, probably the most common understood definition. If you like, whatever the goal is for our stakeholders, for the system and processes and the people in the business, whatever that purpose is, the system that meets that purpose, that supports that purpose, is likely to be a higher quality, perceived to be a higher quality system. Now that's fine, but it's not a very easy thing to measure. That's kind of our slight difficulty with this definition. Another common one that's easy to define and potentially easy to measure is this notion of conformance to requirements. A quality product conforms to requirements. And in principle, we can test against requirements, documented requirements, let's say, very easily, and maybe some undocumented requirements. The problem we have is that requirements, by and large, are nowhere near as authoritative, as complete and ambiguous as they ought to be. So although testing that a system or software meets requirements is kind of a relatively easy thing to do, we never have mathematical proof, we never have utter confidence that we've actually met all the requirements, because a lot of requirements are never written down. Another variation on this kind of theme is this notion of, if the cost of a system to build that system is high, then if we communicate that cost to our users and why that cost is high, then it might be perceived as a higher quality product. Now, the example that's easiest to quote is something like if we make our widget out of 9-carat gold, clearly it has some value above and beyond it being made out of a piece of aluminium or something. So the cost of development has an influence over people's perception of value, because higher cost tends to imply higher quality by some measure. But there's also looking at it from the customer's point of view, where the quality of our system might be gauged on the basis of the price that our users, our customers, our stakeholders, the price they're willing to pay. Now, the higher the price that they're willing to pay, their perception of quality is going to be based on whether our system can be delivered against that price, maybe a fixed price, let's say. But this idea of delivering to a price takes no account of the fact that meeting the target price, the budget, and delivering on time, let's say, does not necessarily mean that it's a high quality product. The product might be full of bugs all the same. Now, some folk love the idea of a standard, and that we can define a standard for quality, let's say. And so quality is compliance to a well-known standard or an agreed standard. But what we find in the software engineering standards in particular is they don't give us standards for quality so much as standards for process and behaviours in projects. And if you like, it's an act of faith that good behaviour in a project, behaviour to good standards and an agreed standard, will automatically lead to high quality. And this is an act of faith, I'm afraid. So it makes it hard to suggest that our target for quality can be derived from adherence to some standard or other. Another angle that we can take is quality is value, literally. So the more valuable a product or system or service is, the higher quality it must be. But again, that's not a complete picture. It's a one-dimensional view, because there are very cheap and cheerful products that potentially have great value to our stakeholders and our customers. And by being cheap and cheerful, that might mean that they have lots of bugs and they are not, by most people's general perception, to be a high-quality product, even though they are valuable. Now, another dimension to this is that an end user might say a product is of high quality if it gives them a good experience. It allows them to get their job done, to achieve whatever goal they have, and their perception of the experience is it's a good one, a smooth, efficient and effective. But again, this is a subjective and a very personal view of what an experience is. Experience is a human thing. It's not a technical thing we can measure in any systematic way as an attribute of the system itself. It's a measure of people's understanding and value, perceived value of using a system with utility. Finally, I want to look at a definition from Jerry Weinberg, which is this idea of quality is value to some person. And it's a very simple and short definition, but it has most of the meaning that we've looked at in the previous 7, in that, firstly, it's a perception, and it's a personal perception typically. And obviously, every person involved in our project as a stakeholder has slightly different perceptions of what quality actually means to them. So quality is value. Okay, fine. And value, again, is a word that's a bit vague, but covers all the aspects of utility, performance, security, all the non-functional attributes, plus an experience that is possibly enjoyable, but certainly efficient and undistracted, if you like. Let me just look at an example to explain this difficulty we have. For example, the weather. So rain is great for farmers and their crops. Of course, plants need water to survive. But rain often is a blight on tourism and tourists who are trying to enjoy good weather as part of their experience. The wind is essential for sailors and windmills and wind turbines, that kind of thing. But it's often bad for the rest of us. Strong winds are not an enjoyable experience. So quality, like weather, can be good or bad, but it depends on who you are, what your context is, what your goal is in whatever experience you're trying to take on. So quality is a subjective perception. It's unique to the human being that's experiencing it. So, for example, a supercar might be a dream for some people, but completely useless for other practical purposes for other people. Fast food is loved by millions, but personally I hate it. Eating isn't just about putting food into your body. The whole notion of choosing a recipe, buying food, cooking, having a warm conversation, an enjoyable social experience as part of the eating experience, that's what food means to me. So quality is a much more sophisticated experience than it is than just enjoying the taste of something as you eat it. So quality, the best way to look at it is it represents a relationship between a product and a user or a stakeholder. And different stakeholders have different perspectives and different perceptions of what that experience and what quality is. Quality is not an attribute of a system. It's if you like, a loosely defined definition of the experience that individuals have with the systems that they are using or perhaps testing. Now, in the heads of our stakeholders, the ideal of quality, the model of quality, if you like, that prevails is in their minds. It's not in the product itself. And that's an important thing that we need to recognise, in that we can't measure attributes of the system to understand the measure of quality that some user or stakeholder might experience when they actually get their hands on the system. And that's why users are very often find different issues to report in testing, in acceptance testing obviously, than maybe system testers or developers when they are doing their testing. But at the end of the day, stakeholders have a model, a mental model of quality in their minds. They know what suits them, but they find it very hard to articulate. But it's quite clear when something does not meet that expectation. And the silly example I've got is, the user might have the ideal of a Formula One car in their mind, but when the delivered car arrives, it might not be a very happy experience. Again, I'm probably spending too long on this, but I don't think it's you can overemphasize this, that quality is a relationship. It's not a thing you can count. And quality as a word has a lot in common with other words that we use, like risk, comfort, usability, facility. These are personal experiences and personal perceptions. It's hard for people to explain these things, but we use the word quality as a generally good idea. The problem we have is quality is all-encompassing. It includes all the aspects of our systems and experiences of those systems in testing and in production. So quality is a collective term for these and many other difficult concepts. It's a term that means all things to all people, and that's a real challenge for us in our conversations. So this is why I try and avoid the Q word. But at the end of the day, you need to have a conversation with your stakeholders to understand what they mean by quality. So they might be using this notion of fit for purpose, or meets requirements, or price, or value, or experience as a whole. We have to ask for examples to get an understanding and to get into the heads of our stakeholders to understand what they perceive to be high quality or otherwise. We want an insight into their thinking, into their quality model, let's call it, and which is their understanding of what makes a system good and acceptable. So if we can learn a little bit more about how they perceive quality and the mental models they're using, it gives a hint to the test models that they would favour. So if their perception of quality is the system supports end users in the delivery of services using specific user journeys, we know user journeys are important. We know we need to test against those user journeys and use performance against and with those user journeys to deliver a good testing message that says the system works in the ways that you expect and require. If we can understand what the quality model is, whatever it looks like, and we can negotiate test models that have meaning, if we can articulate those too, these models are the ones we use to explain testing, but also to negotiate what we do for our stakeholders.